Today we're going to talk about ordering processing in Apache Beam pipelines. First, a quick introduction. My name is Sergey Luchenko. I'm a solutions architect at Google Cloud. So oftentimes I work with customers and I write proof of concept for them in Beam pipelines, and I do it sometimes for internal teams. Also, I do publish some blogs and architectural guides, and sometimes I contribute to Beam repo. And this talk is actually about how a particular engagement with a customer turns out that I end up developing a generic Beam transform that is used for order processing. So what are we going to talk about today? We'll talk about what exactly do I mean by ordered processing and why do we care. So we'll discuss the different use cases that's applicable to that. We'll talk about Beam, why Beam, Apache Beam is a good framework for to handle these particular use cases. I will show you what is currently available in Apache Beam today and which transforms and which particular built-in features you can use in Apache Beam to do ordered processing. And I will dive deeper into what exactly is being used under the covers in order for this non-trivial functionality to actually function. So hopefully it will be useful as a general Beam capabilities that you might not be aware of. I'll talk about what else is coming to this particular space. There are additional development that's going on. And if we have time, I'll share quickly the lessons learned, my personal lessons learned from developing this particular transform. So first of all, what is ordered processing? And we know in general kind of what ordered processing is. But let's talk about several specific use cases that we're trying to address. So the first use case is order book building for financial services industries. And order book building here's the definition from Wikipedia that's there. I'm not going to read it. But the idea is like at any point, let's imagine a typical stock exchange that trades different stock symbols, Microsoft, Google, Meta, and whatnot. And it's important for the exchanges to know at any particular point in time how many bids and how many offers were for a particular symbol, for example. And order book in essence, is a collection of list of bids and list of offers at any given point in time. What's critical here is that the events, new bid comes in, new offer comes in, new buy request comes in, they must be ordered exactly in the right sequence. And there should be no gaps in sequences. And so that's kind of the definition of ordered processing, where all of the events need to be processed in sequence, and you cannot have missing events, because missing events means something is not processed and it's critical for a particular use case. There are a couple of other, or there are a number of use cases that could benefit from this processing. And I'm mostly talking about the streaming pipelines. Batch pipelines don't suffer from the problem because you usually have the totality of the messages, upfront, that you have all of the data and you don't have to wait. You can order them in whatever order, sort of semantics of the ordering you have. But most of these use cases are streaming use cases where you need to process data as quickly as possible. But how do you know that it's in the right order, and how do you know that there are no gaps? Right? So again, another use case, for example, processing data from sensors. For example, imagine that you have a temperature sensor that you would like to say every increase in subsequent read from sensor by more than X degrees must trigger something until it even reaches kind of some sort of threshold. Close to real-time clickstream analytics. If you can say that all of the 5 steps required to happen on a particular website occurred before I can buy an order, or I can buy something or whatnot, and they need to happen, that would be beneficial, again, for some cases. Yet another thing that I recently I've heard that could be very applicable is processing what's called change data streams from transactional databases, where you must apply transaction processing from a particular, let's say, relational database to another source in a very specific order, because otherwise, if you don't do it or if you miss something, you will have incomplete synchronization between these data sources. This is all to say that I believe there is a big enough sort of area not covered by many of the real-time processing systems, so that require very bespoke implementations that are hard to do. And so for this particular customer that I worked with, we try to analyze what's possible to do for the order book processing. And we've come up with the idea that, like, in general, you need to have this generic system requirements. Is that in order for the system to be the ordering processing to be generic, the system needs to support the ability to simultaneously handle the processing of thousands or millions of individual either taker symbols, sensors, users, and whatnot. So it needs to be able to in parallel process that. The ability to maintain the state of the processing, that's also critical, is that it's not a simple mapping processing that's often required. You need to keep state, like in case of order book processing, you need to maintain the state of previous orders, and you need to maintain the state of the previous bids and offers and whatnot, and apply to that state every time. Correct. So that's also non-trivial, how to maintain that state between applying different events. So ideally, you don't want to build a very complicated system. You don't want to, it's possible to say, we need to have a relational database in addition to this and additional infrastructure. But how do you build a system that's as simple as it can be? So ideally, you want to have, you don't want to use any additional services outside of the Beam provided facilities, for example. Obviously, low latency streaming processing is important. Here again, we're trying to process events as quickly as we know, okay, this is the right sequence and there are no gaps. In many cases, batch processing for historical analysis is also important. Like you build a system, but you want to reprocess the data that existed previous months, and you just want to be able to do it. And so for these type of, and so what causes the complexity again? So why is it complex? So I believe there are like two fundamental reasons. It's like oftentimes the infrastructure, the messaging infrastructure for streaming data can cause the complexity. Like for example, Google pops up. In general, it doesn't guarantee order delivery. You can structure it to do it in a certain way, but it only works under certain circumstances. Plus, it also requires you to have some certain knowledge of things, of how it's done. Oftentimes, it's also the order when the event hits the messaging infrastructure is not the same order that needs to be applied. There could be delays and whatnot. So some internal order and sequence is important. And in terms of coding, to let individual developers, customers code large-scale order processing from scratch is difficult. It just can be a daunting task to do, especially if you need to handle things like error recovery and reprocessing. So Beam pipelines seem to be actually pretty well suited, like in general, for those generic requirements that I mentioned. They work, and I'm not going to go through the whole list, but in general, they take off the majority of the check marks, with the exception that they actually had limited support for processing out of the box. There are a couple of primitives that I'm going to mention a little bit later, but it does everything, but it doesn't do order processing. And for people to code from scratch, it's hard. Beam pipelines, especially that require complex state and timers, it takes some time to understand how it's done. And many companies are not in the business of like creating complex transforms. So this is pretty much a problem statement, why it's important. And what's available today is that we've added what's called ordered extension. And the reason it's ordered because it's really extension is called ordered. The ordered extension was added in release 256. And so what comes with that extension, what's inside, is it comes with a generic Apache Beam transform that will process elements in order for each key. And it also defines several Java interfaces that the customers need to implement. But these implementations are pure Java code, and it doesn't require any advanced knowledge of any of the advanced Beam concepts. I've also created a reference implementation for the order book processing. It sits in a separate GitHub. But what it does is that it actually uses ordered Beam transform and says, okay, for a non-trivial customer case, this is how this ordered Beam transform can be used. In case you need to do order transform, there are a couple of actually facilities inside of the Beam that can help with some sort of sorted processing. So one of them is DFN annotation that's called require time-sorted input that can sort the data based on the timestamp before it's processed, but it's only useful in batch pipelines. And there is also a sorter extension that uses a somewhat sophisticated way to sort data that doesn't create out-of-memory problems. But again, it can be useful in some cases, but it's usually relatively narrow. So the question becomes so can any data be processed in order? And the answer is no. And there are reasons for that, and we'll explain why. So the data ultimately, before it gets into this generic transform, needs to be in a specific shape. And that shape is, you can see it on the screen, and key and event are generic types. Key and event can be any types. What's important is that the long key in the second sequence number, and that long key must be monotonically increasing, and that long key must be kind of unique per key. And so, in essence, the way to read about it, to think about this is you need to send to this transform a pickle action that's keyed but by, let's say, stroker ticker symbol, correct? Microsoft or something like that. You need to say, this is event number 1, event number 2, number 3, number 4, and the event itself is buy order, sell order with prices and whatnot. The way transform is coded is that you don't need to, it can provide the initial sequence number can be any number. You can code it in such a way that the transform will determine what was the actual initial sequence number. You can optionally tell the data can optionally tell the transform, but that's the ending sequence number for a particular key, and that would help with certain cleanups. And currently, the pipeline needs to be written using Java SDK. And so if you need to use other SDKs like Python or Go, then there are ways to how multi-language pipelines can wrap up with the SDK. So, and how does it work? So this ordered event processor, part of the customization, part of the instantiation pipeline construction, you would need to provide a class that implements event examiner interface. And the process element is implemented by the transform itself. So when the data starts coming in, every data for every key goes to an individual instance of the transform. And what the process element will do, it will allows the event examiner to tell it whether that's an initial or the final event for a particular sequence. And then that transform will manage several objects inside of the Beam state. And these Beam states will be managed per each individual key. And there are 3 kinds of states. The important ones are buffered events in the sense if it doesn't know that the particular element that just came is in the right sequence, it will just buffer that element in the state. It does maintain mutable state, and mutable state is the business object that maintains the state. Again, in terms of ordered processing, that will contain the list of the active bits and offers, etc., per a particular key. And it also maintains the processing status. It knows what was the last element that was processed, how many elements for a particular key are buffered, and etc. And most important, it knows the last element it successfully produced. So it maintains the notion of the sequence. So once it knows that the event is in the right sequence, it will mutate the state. In essence, it will say the state applied this particular event. It's in the right sequence. And the state will produce the results, and the processing results are what's been output to the consumer. It's a big collection that gets sent. Additionally, it can produce either on timer or for each event, it can produce the processing status per each key. It can tell you what was the last event that was sent and the number of buffered events for a particular key, etc. So this is how the mechanics of doing that. It's a little bit oversimplified picture. There are additional pieces like looping timers. In general, this is what's happening inside of that transform. How does it work? The critical part, and sometimes it's not known, is that Beam guarantees that only a single stateful DFM will process a pickle action elements at any given time for a pair of key windows. And what it does is that it avoids the need for you to do any kind of complex synchronization between multiple workers, between threads and whatnot. So we're relying on Beam Guarantee to say for every key, for every window, it's going to only process a single event at a time. We also use what's called the order at least state, which allows for an official insertion of the elements into the buffered state. And so, and it's also read them already pre-sorted. And so there is no in-memory sorting or anything that will cause a huge kind of memory pressure on the things that will blow up the pipeline. So those are kind of the main reasons why it works. I'll go through the several slides pretty quickly. So is it too complex? No, a customer implemented it successfully and the customer who had like a typical Java developer was able to implement this pretty successfully in their production. So, and isn't too simplistic, and how do you detect things that get stuck and whatnot? And there are ways how to deal with like stack processing and whatnot in the using processing state. The performance is actually pretty good. We tested, for example, 100 million orders for 5,000 securities, pretty much like 1/5 of the NASDAQ trading. And it was processed pretty well with the pipeline that wasn't tuned or anything like that. So out of the box, it works pretty well. There are disclaimers. It's like, if everything goes to a single key, you will have a problem. But that's the typical pitfall of any order processing. Is it expensive? And the answer is no. Here's the snapshot of a cost estimate for this pipeline from Dataflow UI. So it doesn't break your budget. The end result is simple pipeline. This is an example of fully functional pipeline. The core thing is like encapsulated in single transform. I'm going to skip the gory details of what exactly you need to do in terms of implementing the interfaces. What I did is all of these examples are documented in the separate open source GitHub repo that has the link and has a cookbook with explanation what these methods do and do it. So it's a little bit above the typical Java doc documentation that exists. Is there more that's coming? What's important to know is that we're finishing another mode of processing ordered events, and that's where there is a global sequence number rather than a per key sequence. And the idea is like, if you have a monotonically incremented sequence, like for example, for change data capture, that a transaction ID is monotonically increasing, but it affects a number of tables, for example. And how do you do it then? So I'm working on the model, on the mode to implement that. And the way it's going to work, again, technical details, but using kind of global signal tracker and using site inputs to communicate with the transform to let it know when the processing is done for a particular sequence. My lessons learned is that you guys can run pretty complex transforms and you can publish them yourselves. If they're generic enough, you can publish them. You, as a developer, as a Beam developer, I recommend that you poke around in places like Beam states, take a look at the timers. One of the biggest things that I knew before, but it really saved me kind of from when developing this transform is using unit tests, and especially kind of learning how to do coding unit tests for streaming pipelines. At some point, you have to run kind of actual integration tests because every runner is slightly different. So you kind of want to push the limits and test it to some edge conditions and see where it starts to kind of fall apart. And the end result was like, again, we end up implementing looping runners for certain things. And thank you so much for coming. I understand it was a pretty quick sort of run through that. Feel free to reach out to me if you have questions. If you're working on a project, there's my contact information.